Okay, so system design time. In this video, we are going to follow the certain steps in a system design interview to solve a well-known problem called design a URL shortening system. So let's get started. So the question is to ask you to design a URL shortening system. Essentially, we are mostly focusing on the backend service part. So let's see. Usually the first step in a system design interview is to try to scope the problem. So this usually started with asking some clarification questions with the interviewer to confirm what are the feature requests we are going to build and what are the goals and non-goals. So let's say the feature requests. So let's say we have two major feature requests. The first one is about URL shortening. So for URL shortening, so the user is going to send the request with the original URL, and then you're going to return a short URL to the user. And the second feature request, which is about redirection. So this feature is, let's say it is about, let's say I'm a user, I send the short URL, and we are going to get the original URL, and then further redirect the user to the original website. So let's say there are some other feature requests we are not going to cover based on the conversation with the interviewer. Let's say the non-goals. For example, we don't care about, let's say, URL deletion, like URL deletion or URL update, or we don't care about like custom URLs, whatever. So, and we also don't care about like UI UX, front end, whatever. So those are the non-goals for this system design question. So let's start to focus on those feature requests. So we are going to mainly focus on two feature requests, the short URL shortening and the URL redirection. So the next step is about doing some constraints analysis. So in this part, you usually collect some numbers from the interviewer. For example, daily active user, and do some traffic analysis like storage analysis, whatever, to understand the constraints within the system potentially, and also you have a better idea about what is the system you're currently trying to design. So let's say we have 100 million daily active users. Let's say each daily active user is going to initiate one shortening request per day, and let's say they're going to have 10 redirection requests per day. And for this one, let's say suppose we have one shorten request per day, and we have 100 million daily active users. So this is going to have, let's say, 100 million divided, let's say, 3,600 seconds per hour and 24 hours per day. So this is going to bring to like 1K for QPS. So we have 1K queries per second. Let's assume that we have 2K for the peak QPS. And also for this one, 10 redirect requests per day, so it is about 10K per 10K QPS. And let's say we have 20K for the peak QPS. So it makes sense. It's not too much of the traffic. Usually, a normal server can handle like 1K QPS easily. So I think this one, this is not a huge service that we are going to try to build. So let's say let's do some data storage analysis. Let's say we have for each URL we are going to store 600 bytes in average, 600 bytes in average for the original URL. Let's say 8 bytes for the short URL. So because we have 800 million URLs per day, and so for this analysis, it's okay to do some estimation. Let's say 4 or 8. It's okay for us to just say it is 400. It is just 400. So let's say it's 400. This 100 million is like 0.1 GB, and then so this is per day, and we have 365 days per year. Let's say this is this means 300, and then let's say it is 5 years. So what is the total number? So it is like 40 times 365 times 5. It is about so this is about 37. It's about 73 terabytes in total for the next 5 years regarding the storage. So we have then the daily active user, the traffic analysis, the storage analysis. I think that's pretty much it, and we have a good understanding about what kind of system we are trying to design, and also the data storage gave us some idea about what kind of storage we are going to try to use in the next step. So the next step is usually it is about the system design overview. So it's a system overview. So in the overview part, usually just list the general infrastructure about the system, and also you list the different components you're going to have and the data flow between the different components. So let's say I'm a user and I'm going to initiate a HTTP request to the service. So first of all, it is going to hit the load balancer, and then after the load balancer, it's a bunch of the web servers or front-end servers. And then after the front-end server is going to hit our backend server. It is going to send the RPC request to our backend server. And by the way, before this backend server, there is also going to be some load balancer before it, because we try to avoid any single point of failure. So we are not going to have like a single front-end server or backend server. So we are going to have a bunch of them. Let's say for the backend server, it is going to talk to the backend to the database about the data storage. So it is going to talk to the data storage. So for example, let's say I'm a user, I want to do shortening, then we are going to write the original URL and the short URL into our database. And for the redirection, we are going to try to read from our database about the relationship between the short URL and the original URL. And also at the same time, before the DB part, potentially we need to talk. We can talk to some cache. So for example, for the redirection, if there is already the key value pair, which is a short URL and the original URL pair in the cache, then we won't bother to query the database for the data. So usually the cache is in-memory cache, which is much faster than database. And also for the DB, to avoid single point failure, we are going to set up the master slave for data replication to avoid any single point failure. I think overall that's pretty much it about the general infrastructure. About the backend side, so yeah, so we spent a couple minutes talk about this with the interviewer to try to explain the data flow and also the different components we are going to have. So that should be good to cover the system overview part. And the next part is about some detail design. So depending on the interest for the interviewer, they may ask you to design different parts. So for example, if you have a lot of experience with database, they may ask you to design the database, the tables. You're going to use a data schema for each table, and ask you some, for example, like data sharding, the replication, whatever, a bunch of questions to dig as deep as they can to see how much you know. And also, they may ask you about the logic for the backend server, what it is about, what it is going to do. So let's dig into different components about the detail design. So for the DB part, due to the data volume, which is 73 terabytes, and also the nature of the data, so we are going to, I think a good option is we can use NoSQL to solve this problem. So NoSQL, why we choose NoSQL? So the difference between SQL and NoSQL is that when you don't, if there is a huge volume of data, usually you choose to use NoSQL. So for NoSQL, you're not going to do some massive selection to do join between different tables, but from data serving side, for this problem, we just need the key value pair. So it's pretty natural to use NoSQL for this problem. So let's say we use NoSQL, let's say we use Bigtable. So we are going to define a table, let's say URL table. So for the URL table, we are going to have the row key. Let's say we have the row key as short URL. And for the column, we are just going to have one column family. And also for one column family, we are just going to have one column. So the column is going to store the string, which is the original URL. So that's pretty much it about the database schema design, the table schema design. And let's say the next part, we are going to talk about the logic of the backend server. So backend server. So what is the backend server is going to do? So the backend server is, so essentially the backend server, after receiving the RPC call from the frontend server, for the shortening, it is going to, it is going to generate a unique ID and use the base 62 formats of the unique ID as the short URL. So this is basically what the backend server is going to do for the shortening and also for redirection. When a RPC call when we get an RPC call for that, we are going to try to see if there is anything within the cache. If it is cache hit, then we are just going to get the original URL from the cache and then send back the response to the frontend server. If it is not cache hit, then we are going to query our database and then at the same time update our cache and then return the response to the frontend server. So essentially it is shortening. It is like we receive the RPC call and then we are going to generate the UID and then store the short URL, the pair of the short URL and the original URL into DB, and at the same time update cache, and then we are going to send the response to the front-end server. Like, we are going to send the status code to see whether this operation, like the DB operation, is successful or not. So for redirection, RPC call, and then we are going to query cache or DB for the original URL, and then we are going to send the response back to the front-end server. So that's pretty much it about the general logic of the backend server. So how are we go? So I think a very common question is, how are we going to generate a unique ID? So for generating the unique ID, there are a couple ways to do it. So the first way is, so there are several ways. First way is we could use some hash function, but for the hash function, you need to deal with the collision. So as long as collision is dealt properly, I think it's okay to use some hashing. There are a lot of things for you to choose from. So like MD5, whatever, SHA-1, whatever. But for this one, I would just use another way, which is a more common way used to generate a unique event ID for a lot of the system. So here we have, let's say we have the unique ID defined as 64 bits, which is 64 bits. So we are going to have different segments for this unique ID. So first segment is going to be the timestamp. So the timestamp is, we could use milliseconds for this one. And the second one is we are going to record the data center ID. So you know that in the big company, in the big tech company, there are multiple data centers deployed worldwide. So first of all, we will have the data center ID, and the other thing is, the next thing is machine ID. So you know that in each data center there are a lot of machines, and we need to identify the different machines within the data center. And also the last one, we need to leave the rest of the bits to do some. So for example, if a request is sent at the exact timestamp to the same data center to the same machine ID, then we need to have the rest of the bits to say to tell the difference between the different requests. So let's say for the first one we have 64 bits, and the next one we have 5 bits, and the next one we have 5 bits, and the next one it will have 12 bits. So usually for this kind of service, we could deploy it in, let's say, 2 data centers. So this one, it is enough for us to deploy the service in 2 data centers. And because due to the nature of the traffic, it is just 1 kqps for shortening and 10 kqps for the redirect. So we have 5 bits for the machine ID, which means we are going to have up to 32 machines here. So I think that should be enough. And also, suppose a request is sent to our service at the exact same timestamp and to the same data center ID to the same machine, then we are going to use the rest of the bits to tell the difference between the rest of them. So we leave 12 bits for the rest, which means we are going to have about 40,000. Yeah, so we are going to have about 40,000. We can get 40,000 requests for the same timestamp for the same data center ID for the same machine. So the rest bits can be set in the code level, so which is pretty easy for that. So that's about the underlying logic for us to generate the unique ID, and we are going to, because the unique ID is 64 bits, so we are going to use base 62 on the unique ID to serve as a short URL. So base 64, it is essentially for you to use all the numbers, lowercase, uppercase, alphabet. So essentially it's something like that, which is going to be quite user friendly, because if you return something like sharp or $, whatever, it doesn't look very good for the users. So I think we should be able to cover most of the things about this system design question. Other than that, I think it's really up to the interviewer to ask different questions, but I think we should have already covered most of the common questions for this system design question. So for this one, there is not too much of the scope to dive into. So if you're interviewing with a senior position, I think this question won't be enough. There usually is some other follow-up questions to ask you. So that's it for this question. If you have any question about anything, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.